Okay, this is question number 1 on the graphing quadratic functions test. This was the part where you weren't allowed to use a calculator, you had to do it by hand. And so it's set up like this, and I need 5 points is what I need. So I'm down here, so I've got the picture here already drawn on the grid, and I'm going to put 5 points down here, x, y, and I already know one of the points. One of the points is the y-intercept, and that's right here. That's the y-intercept. And so that's going to be 0, 8. Okay, 0, 8. I'm not sure where it's going to go on the table. I'll just put 0, 8 right there. So I've got one of the points, so I'm going to graph that 0, 8. So I'm going to go on the y-axis up 8. 1, 2, 3, 4, 5, 6, 7, 8. Right there. 1, 2, 3, 4, 5, 6, 7, 8. So that's where that is. And that would give you half a point. But what I really need is the vertex. And I noticed that A equals 1, B equals 6, and C equals 8. So I'm going to use, unless you're Tom Loveday, I'm going to use the Valentine's formulas, which is B, negative B over 2A, comma, C minus B squared over 4A here. That's my vertex. Okay, so I'm going to use that formula. So I'm going to do that right now. Okay, and that's going to be the vertex is negative of 6 over 2 times 1, comma, 8 minus 6 squared over 4 times 1. So when I do that, I get negative 3 here, and here I get 8 minus 36 divided by 4, and 36 divided by 4 is 9, so 8 minus 9 is negative 1. My vertex is negative 3, negative 1. So I'm going to put that down here, negative 3, negative 1. And on my graph, do that the vertex in green, so there it is right there. I'm going to put that 1, 2, 3. There's my vertex. Okay, go back to black here. So it turns out that if I'm 3 units this way, and I got up here to 8, then I'm going to go 3 the other way. 1, 2, 3. Whoops, that's too far. 1, 2, 1, 2, 3. That way. Okay, and so I'm going to go up to 8 up there. 1, 2, 3, 4, 5, 6. Okay, here's 8 right here. It's not letting me put a dot there. Okay, there it is there. And that coordinate is 1, 2, 3, 4, 5, negative 6, comma 8. You can see they reflect from each other. I need one other point. Well, it turns out that I need 2 other points. This is factorable. The factors of 8 that add to 6 are 4 and 2. So I'm going to write this as y equals x plus 4, x plus 2. So I get x equals negative 4, or x equals negative 2. Because I'm going to set this equal to 0. When I do all the work, I get that. And this one is going to be x plus 2 equal to 0, and I get that answer here. So I'm going to put a box around those. So I need to graph those. Remember, those are zeros. Those are when y equals 0. So they're both negative 4, 0, and negative 2, 0. So I write that over here. Negative 4, 1, 2, 3, 4. There it is there. And then I want negative 2, 0. So when you graph this thing, it looks like this. There it is there. Okay. Now they also asked you to give the vertex with coordinates. Well, I've done that already. That's right there. I just need to give the axis of symmetry. Well, the axis of symmetry is the x of the vertex. So the axis of symmetry is x equals negative 3. Do not write just negative 3. It's got to be x equals negative 3. So my two answers are really, here's the vertex. Here's 1 point, 2 points, and then you get a point for graphing it right. Each other point is half a point. So that's how you get a total of 5. Okay, I'm going to go to the next question. So here's problem number 2. It says, again, graph each function, label the vertex with the coordinates, and the axis of symmetry with an equation. So this one's a little bit easier in some ways because we get the vertex right away. If we look here, there's the x's lie to you part of the vertex, and the vertex here. So we got the vertex really quickly. The vertex is 2, 5, and the axis of symmetry is x equals 2. Okay, so we got those there. Okay, so we've got 2, 5, so let me graph that in green here, so I could do on the other one. So 2, 5 over 2, up 5, 2, 4. It's right there, right approximately. That's the vertex. Okay, the axis of symmetry, we know that goes right down the middle. Whoops, I didn't change the color here. The axis of symmetry goes right down the middle here. Okay, there's the axis of symmetry. That's x equals 2. Now we just need to pick some points. Well, I can make a table of x's and y's. In the middle of the table, I'm going to put 2, 5. And again, this is really not, well, you can't use this like before, where this is not the axis, sorry, this is not, well, I don't want to say axis, the y-intercept. It's not that. So you can't just jump to that, that's part of the vertex. But I can see that I could do some trial and error here, and I'm going to pick points that are equidistant. So I'm going to go 1, 0, and 1 and 3 are both the same distance on either side of 2, so they should be the same. And 0 and 4 are both 2 away from 2. So this vertex is really important for getting it. Okay? So let's try 0. Let's try 0 in here. We'll do the work under here. Negative a half times 0 minus 2 squared plus 5. This is going to be negative a half times negative 2 squared plus 5. So that's going to be 4 times negative a half plus 5. Negative 2 plus 5 is 3. So 0 is 3, 2 is 3. And I can graph those points. 0 is over here at 3. And that means, actually this shouldn't be a 2, this should be a 4. My mistake, I said it before. This should be a 4 here. So 4, 3. Okay, there's the there. Then we'll try 1. I'll do that work over here. Negative a half times 1 minus 2 squared plus 5. That's negative 1 squared plus 5. Negative a half. So that's 1, so it's negative a half plus 5 is positive 4 1/2. So I need to graph 1 comma 4.5. I need to graph 3 comma 4.5. So I'll put those in there. There's my table to keep track of things. So over 1 up 4.5 is right, whoops, that's a mistake. About right there, about right there. So now when I graph this thing, it looks something like that. There it is there, and I've got all the parts that I need. So I'm going to save this and put this online.